Okay, so let's fix this range mapping. So I'm kind of disappointed with myself here because I realized that upscaling and downscaling need slightly different formulas, and I'm also starting to see why. I'm starting to understand why in the OpenGL world and the graphics world, when you're doing your math, you do floating point math for pixels, and the model for pixels, the pixels have a center, right? I'm starting to understand why that model is the way it is because we're experiencing a lot of problems that may have been easy to alleviate if only we were using a pixel center model. I think, um, but we're already here, so we're just gonna have to fix it. Um, so the first thing I'm noticing here is if upscaling we're going to seal. Yeah, so if the destination range is bigger than the source range, then we're upscaling. And if we're upscaling, we use the seal, otherwise we use the floor. So I'm going to make a command where um, it knows so this is what I need to do for upscaling. So I'm going to take this formula and I'm going to throw it into some type of special seal function that has an option to either seal or floor. So it's not going to be... So... Um, um, hackish, seal, or floor, depending. They're just gonna make a section here. I don't know what to call it. We'll just call it hackish, seal, or floor, depending. That'll be the name of this section. And then within this section, we'll have a function that just, it'll be like, for our use, we want to return an int32, but we want to take a float 32, right? So AAC 2020 poly OGL, and so if it's upscaling, we could call it seal or floor, or floor or seal. Well, FOC I think I use that for the word focus sometimes. So seal or floor was the original ordering I was thinking of. Seal if true, otherwise false. False at floors. I don't know. Let's name it kind of a similar name as these, right? So it takes a float 32 and does this thing here. And we're just going to take a float 32 called float 32. And it's also going to take an int32 called int32. Upscaling. And this is going to be upscaling. So, upscaling. And we'll make a note that, that upscaling is this. That this parameter, the parameter passed in here is supposed to be equal to, like, this kind of formula. Right? So upscaling equals this kind of formula where we're just subtracting the source and dest. Value. This right here is our value, right? And this is, so over here, what's going on is, you know, one is the destination range, one's the source range, so we can make a note of that above this. And this is the value, right? So this is the value that we actually want to floor or seal. And it's pretty simple. It's just, you know, if int32 greater than or equal to 1, and I'm wrong about where this code goes, aren't I? Yeah, because this is going to be... Yeah, it should be in the common. This should be over here. My bad. Unless we're making a... It looks like we decided to make... versions on both sides. I see. Fragcom functions if it's OpenGL, and then if it's... I see. So we kind of logically divided it like this, so the polyfill section is... Some functions are written so that they could work either way, but okay, I guess I'm fine with that, if that's how we want to roll. That does leave more possible problems if we don't write things correctly, though, but... sure. Let's do that. Let's, I mean, I think at the very worst... Huh. I'm not sure if I like my organization of this, but I kind of understand why I did it, but... Because it's this division here, where, you know, OpenGL fragcom stuff is over here, if it's OpenGL, but then polyfills are, you know, over on this section, so I kind of... Yeah, okay, fine. I guess that subdivision of effort kind of makes sense. So we have a seal native. We create a floor later, we'll put it here. Okay. Yeah, and if we're upscaling, we want to seal. right? Okay. Okay, so we can say int32 seal or floor results, right? So the seal or floor result is going to be this. We're going to set it to either this, or alternatively, we'll set it to floor. So seal F32 and then floor. So just call it FOLO U32. And for this code, we don't have a floor yet. So up here, we have different sections, right? Seal and round. And it looks like we kind of grouped these in two sections. So let's kind of steal this. So we said, hey, if we create a floor function, this is where it's going to go. So let's take this and paste it. And anywhere we see the notion of sealing, it's no longer seal, it's floor. So seal right here, floor, right? Not seal here, it is floor. Right here, same deal. I'm pretty sure we have like a floor F in math.h. We'll find out if that doesn't work, but we're just gonna assume it is in there, because they have some consistent naming conventions within the C headers. Like the names are kind of weird, but they're pretty consistent. Seal, floor, round, right? So seal, floor, and round is what's in here. So that means down here, seal, floor, and round, or seal, floor, round is what we're calling it. So if we highlight this, we highlight that, we can see them. And so now that we've created these seal functions, we actually have to correctly use them, right? So this seal F32 takes a float 32 and returns int 32, right? So it just has a cast, and it calls seal native, which is a wrapper for, well, this is totally wrong. This CEL is not a seal, this is the floor stuff, right? So this is our FOLO for floor, FLO for floor, and then FLO for floor. And I'm not a fan of what I'm doing right now. I think this code is ugly. However, it's ugly code, but we need the code to pass our tests first, right? And I'm thinking that I'm questioning how I'm doing things, but right now we just need the code to pass the test. So that kind of sucks, but that's the reality of what's going on here. So this thing is going to be so we need more room for for calculating this. So these are the ranges. This is the cluster size. This is the value on the range 0. And this is the value on the range, but it's been zeroed out, right? This is the input value on range zeroed out. DP right here, this whole thing right here is the destination pixel, right? So this right here. So I just want to rearrange this to where everything kind of makes sense. So this is value 0, this is value 1, right? Right, this is the range, right? So this is the range. And these are values on those ranges, right? Because we zeroed everything out. So they're actually values on ranges. But then after we add this new origin, right? After we add the new origin, then this right here, this section right here becomes DP. So this right here is DP for destination pixel. But then we also want to so this is mostly right. That's mostly what we're looking at here. But then after we've done this, we want to instead of seal F32, we want to do seal or floor F32. And we want to take that range, right? So we want to take that range, right? So this D, this range here. But we need to take this range and we just gotta put it in here. And So for this is x's, right? So we just put x's in here. And this is upscaling, right? So it takes a upscaling variable, and then it takes this, and that goes into that function, and then we're good. And then this is what? One, two, three, four. 1, 2, 3, 4. 1, 2. Okay. So this is a mostly working formula, right? So so first thing we want to do is we want to go find those macros. We're defining this kind of stuff, and we want to put them in here. So we got these 3-letter macros, and we're just going to say, hey, define so we have seal or floor F32, AAC 2020, fragcom, cough F32. And then down here, we want to define seal or floor F32 as AAC 2020 poly OGL seal or floor F32, right? So let's make sure that we have 4 matches. So that we have those 4 matches. And we have the 2 different namespaces depending on where we're running this from. And so we got seal, we got round F32, and then we have another function that is pretty much the this is just going to take the same logic over here, right? So we can just steal this. This is ugly. So seal or floor F32, right? This function here. And instead of calling poly OGL, right, we're going to call fragcom and fragcom. And we have seal, but we don't have floor yet, so we're actually going to have to make a floor, aren't we? So floor. And we have to do a floor native. So floor native. So we inserted floor. Here's seal. Here's round, making sure they're all refactored correctly. And we'll just steal these as well. Alright, so the formula that should be used for this, to figure out what I32 is, it should be this kind of formula. So I'm just making a note of that there. But 1, 2, 3, 4, 1, 2, 3, and not quite 4. I believe we have a seal F32, don't we? Yeah, seal F32. So let's just use, you know, seal F32 here. And floor F32. Then we can just make a note. Of what that's supposed to be. And up here, we have round and seal, but we need a floor. So seal, floor, round. So we're going from the bottom to the top, right? Or lower to higher, right? Or actually, I don't really like that order. What do we do here? We have floor, then we have seal, then we have round. Seal, round, and floor makes more sense. So, seal, then round, then floor. Like I don't want an arbitrary order of things. So, seal, round, and floor seem to be the correct order, right? In order from lowest, middle, and high. When you think about, or sorry, no. Floor, seal, and round. Because I'm thinking that up here, up towards the top of the screen, is the lower values, and then down here are the higher values, right? So floor, seal, and round. Okay. And so we got floor. Oh god, I just suck at this. Floor, then round, then seal. My bad. Okay, floor, then round, then seal. Floor, then round, then seal. So we have floor, but then we have a seal in here. So what I'm saying here is that we want to take the round code. So here's the rounding code. There we go. So now we have flooring code. We got the rounding code. And then we got the ceiling code. Let's try to get rid of those colors. Okay. Let's look at that again. Flooring code. Rounding code. And ceiling code. Okay, and then same thing, we want to do in the same order here, so floor, round, and seal. So I'll also make a note of that, right? So I don't anticipate any of this ever changing, so I'm not sure why we're indented twice like this. Then we have different sections. Guess all of our main functions. Okay, let's not worry too much about that, but yeah, it does seem to be the indentation level here. Floor, round, seal. Alright, so this is the order. What's going on here? 1, 2, 3, 4. And the next thing is floor, round, and seal. We have to have them accounted for here as well. So we see round and seal. Round and seal, but then we want floor, right? We want the lowest value up here. So in terms of what these checksums are, we need to not look at those for a little bit, because we want a floor native and then we want a floor F32. And floor native, we're assuming that there's a floor function, right? And then floor F32 is going to be AAC 2020 fragcom floor F32. And then over here, same deal. We don't know what these checksums are anymore because we've been messing around here. And duplicate, duplicate. We're going to take the round, or not the round, we're going to take the flooring that we added in here. Floor native is going to be floor F, right? Or it looks like we have wrappers for them over here. I don't know why we did wrappers, but let's keep the code consistent. So if that's how we're doing it, then that's how we're doing it. Right? And then make sure everything kind of matches, right? So floor, 2 floors, 2 rounds, 2 floors, 2 rounds, native and F32s. Okay. And then for the seals, let's look at the seals. So we got seal, which is native here. Then we got this seal right here. We got this thing right here, seal native. Okay, and this is all poly OGL. That makes sense. Seal native, seal F32. And these functions exist. Let's make sure these functions exist. So we look for them. Oh, there they are. Seal or floor. So seal or floor, that's kind of a wonky kind of function. But I don't really want to do code like that, right? We're introducing branches into the code that we really don't want to be introducing. But at the moment, we don't want to... We just want the code to be correct, right? If the code's not correct, the performance does not matter. So, as much as I hate doing this, like I really do hate what I'm doing right now, I just need the code that I wrote so far to get working. So, so now we got this, you know, seal or floor F32. And now if we go over here, look for that seal or floor F32 should be being called down here. Alright, so seal or floor F32 is getting called from here. And we also need to rework this function as well, right? So this is the same kind of deal, but it's on the y-axis. So it's going to be easier just to nuke everything, I think, and start over, right? So make sure our braces are balanced here. So we got this, and then we got this where we're just adding the new origin. It's a mostly working formula because we're going to wrap it in, like, are we upscaling or not, right? So let's steal all this because it looks like the brackets are balanced, and let's just do everything for the y, right? So let's go color code where we're seeing x's. Okay, anywhere we see an x, and we're just going to replace that with the y, right? So it's just the y section for the code. Okay, so, the chunk size right here. Um, let's explain this formula, right? So right here, this formula mostly works, but it has some issues. That's why we have it wrapped in this thing. You can have this conditional here, right? But this formula right here, we take the input range and the output range, right? And we add 1, because to account for off by 1 errors. Right, so the number of pixels on the input range, the number of pixels on the output range, right? That's what's going on here. And if we take the number of pixels on the input range divided by the destination pixels, we get a thing called CS, which is the chunk size. So, this is how we, for each unit of the source, how many chunks in destination are we getting? I believe that's how that works. Well, let's actually go diagram this. Let's go diagram this for a second. So we have something like, we're mapping, you know, right, and we're mapping it down. We're mapping it down to something like this. Right? So this is the source and this is the destination, right? And we're trying to map a value here down to here, right? So we take the source range, which is 6, divided by 3. So we got 6 and we divided by 3, right? And we get 2. Wait. Hold on. We take the source, yeah, 6 divided by 3, we get 2, right? So the chunk size is 2, right? Because these chunk sizes are, so that it's the source chunk size, right? Is this chunk size here? And then once we have the chunk size, we say, here's the source range. So here's the source. And we divide by the, does that make sense? That doesn't make sense, does it? Hold on. So source, so 6 divided by 3 equals 2, right? 2 times 3 is 6. Okay, that's the chunk size. And then we have the range, the source range, which is 6, right? 6 of them. And so we have, oops. So you have 6 things. Oh, actually, no. My bad. So I was looking at this. This is actually the value on the range. That's why I'm confused. This is the value on the range. So the chunk size is this. This is the value on the input range. So you take a value on the input range and you divide by the chunk size. Okay, that makes sense because the chunk size is these chunks. So it's like tile map math, right? So these first 2 values are within this tile, these 2 values are within this tile, these 2 values are within this tile. Okay, so yeah, now that makes sense why we have this divided by that chunk size. So chunk size could be thought of as like a tile size. If you want to think of the math as like tile map math, that can make a little bit more sense, I think. So it looks like we kind of refactored that correctly. So let's go give this a run, see if we can... Well, actually, hold on. We have some macros we have to clean up down here. So it doesn't really matter too much, but let's try to clean this up. So let's blast this away for a second, because we decided that we wanted to have these seals on the top, right? Or actually no, we wanted the floors on the top because they're the lowest values, right? So undef, floor native, and then undef, floor F32, and then down here we want to undef seal or floor F32, right? So seal or floor. And that still is like a lot of stuff. I actually think I want to make a little divider here. Because we have like sealing and flooring functions, and they're all kind of like, there's a big cluster of just seal and floor functions. So let's just give them kind of a little divider section. And then let's continue with the checksum of, you know, what's going on here, right? So alright, so 9, 10, 11, 12, 13, 14, and 15. 15 macros, okay. And the next question is that correct? Right, is that actually what it is? Are there 15 macros? Let's go look up upwards and make sure that that is correct. So once again, we were thinking that having a little divider, because there's just a lot of stuff going on here. And okay. So now that we have this, we can kind of like start filling things out. But we also want to okay, so this one here is going to be blank, right? This is a blank line. Okay, so 7, 8, 9, 10, 11, 12, 13, 14, and 15, right? So we're assuming that there are 15 things here. And that means we should be able to just column select and drop them down right here, right? So we should be able to just go like, bam, throw them in there, and all the checksums should be good to go, right? And that looks like the case, right? All the numbers line up. Now the thing I don't like is that these two sections are kind of like they blend into each other. So let's just say, make this orange just to make it different. Alright. Okay, so now that we have that, let's just try to get this running. Because I'm sick of this. I am really sick of this. I didn't think it would be like, I didn't think it would be a week from now and I'd be like, hey, still trying to figure out that one formula. Like, I know I said I wanted to go slow, but geez. Set but not used. Seal or floor. Let's go look at our code. So the seal or floor function. So here's the result. We actually have to return that. Let's also make sure we're doing that in the seal or floor code here. So seal or floor, I'm going to guess we didn't. Indeed, we did not. So same thing. We want to return this result. We either seal or we floor. Same deal over here. Maybe we want to make it exactly the same. So we want to say, take this and say, you know, define seal F32, and then define floor F32, and throw that in there just so that we can have the syntax, or not the syntax, but just have the have the body of the function written the exact same way, right? So it's not the best. Yeah. And then also remember, if we're going to do this, we got to actually make them have the correct values, right? So that could be a big problem if we didn't get rid of that, right? So, okay, so if we look at this, right, we got seal F32 and floor F32, right? And they're all in the places that we think they should be. We might want a little bit of... sure, no, let's just keep it like that. Actually, I do like a little bit of space right there, just to make it a little bit more readable. Just one more space. And that means that right here, we can just take this, right? And we can just say, this is a bad idea, what we're doing here. But right, the idea is that now, the code over here should be compatible, right? So we should be able to, if we want to take this code, we should be able to just take this code here that we wrote, and we should just be able to throw it in here, right? We should be able to, like, bam, throw it in there. And that should be that, right? So now the border is a little bit different. Also, this is not called fragcom, right? This is just a different namespace. This is polyogl. Okay. I don't know if I really like what I'm doing here with the polyogl namespace, where some of these things aren't really polyfills. Let's not worry about it too much. Let's just try to get it working, right? So, we've cut and pasted stuff everywhere. And... okay, to do. So the error to do, we want to get rid of that now, right? So that was in fragcom. To do floor or seal depending on upscale or downscale, right? So that is actually what this is, right? So seal or floor F32, and it's gonna, if we're upscaling, we're gonna seal. Otherwise, we're flooring, right? And that's just what I empirically... choosing which one to use, like a seal or a floor, that's just based on my observations of what gives me the results my tests want. So now we're just gonna hopefully pass all our tests and... well, I mean, so I know this I'm hoping this function won't fail, but there are other functions that we might fail because they were written at a different time. So, so MG3, let's go look at that. So let's go look at, so fragcom, and if we go look at simplified whatever the heck test, let's go find that. And let's hope that it's not the function that we just wrote that's failing on us, right? So, this note right here, let's make sure that that is indeed the... okay. So, meta test number 3. I think that is what we just worked on, isn't it? So, let's go plot this out, right? Let's go plot it out. So, it looks like that group of tests so this is the range, right? So this is the range right here. And let's just look at this group of tests and see if it actually makes sense or if we want to change our minds on this. So the input range is, 0 to 11. And the output range is half of that, right? So it's 0 to 5. So let's just steal this. And okay. And what's the failure here? Is the failure, it's the x's that are failing. So let's look at the x's. So we got a 2. Right, so we're at 2 right here. And the output we're getting is a 1. Okay. So is that sensible? Well, 12. Looks like this is divided into 3 chunks here, right? 3 times 4. Oh, no. 4 like this, right? Maybe not exactly like that. So here's the kind of mapping that we're assuming. That we have this 2, and we want it to map to 1, but instead it's mapping to 0. So, did we not already just solve this problem with, like, this range exactly? Didn't we already have, like, a specific test case that we wrote out, and we're like, we wanted to test certain scenarios, right? We had certain scenarios, and right, so this test case, I thought, so there's a 2 going in, and we're expecting a 1 to come out. Instead, we're getting a 0. Okay, so let's make a note of that, right? So, this is what we want. This is what we're expecting. And this is, so this case is failing us. So let's mark this. So every one of these comments has like a little test case for like what the specific edge case is that's kind of failing us. So let's kind of keep with that and say, okay, it is 1 on a, actually it's 2 on a 0 to 11 map to a 0 to 5. Yes. Now, instead of getting 0, we're going to expect, oh, hold on. It's a 2. Right, it's a 2. 0, 1, 2. It's a 2 on this 0 to 11. And we're just expecting it to give us a... Okay, so if we can't get this to work, we're going to make sure that we know... We're going to change around the functions to be upscaling functions and downscaling functions, right? So, because right now this is ridiculous. Alright, so we'll write our functions where we'll just make 2 functions. One will be an upscaler and one will be a downscaler. Because this is starting to get ridiculous. Right, so on this range, if we select a 2, right, we're going to expect this 1 out. So let's take this and see if that passes, right? Because if this passes, it means that the function we wrote earlier is just improper, right? So we've got to see how we did those CL floor functions and see if we screwed it up somewhere. Oh yeah, and then also, since we're adding one more test case, there's 1, 2, 3, 4, 5, 6 items here, right? So now we have 30 in here. And then we also need to make sure that we go through 5 test cases now. So 5 minus 1, because 1, 2, 3, 4, 5. 5 test cases. Okay. So let's run that. And we put this test case last because we're expecting it to fail. Okay, so that's interesting. So 2 went in, and then we were like, we know the range is this. This is the input range, and a 1 came out. So let's make sure that we wrote our code right. So if upscaling, then we seal, and otherwise we floor, right? So seal or floor. Okay. So then didn't we do it over here? Yeah, if upscaling. Let's make sure this function's right. So where is this function defined, and do we not... so over here... Yeah, we just seal. Or a floor. Greater than or equal to 1, right? So if it's true... greater than or equal to 1. And yet... Here we are with a function that, okay, so I'm thinking that this, that this is not written correctly, that when we transcribed it, somehow it got broken. Like, this is not the same thing, right? So, the only way we can really figure that out is if we, make sure So we're just gonna have to call it, make sure the values match, because it seems like whatever is over on my left monitor doesn't actually match the logic I've kind of inlined here. So we're gonna take this and say, we're gonna take this and shove in all these parameters, right? So we're gonna give it, we're just gonna give it the x values, right? So we're just gonna say S1, right? And then S0, and then, hold on, this is SI for input, that's S0, okay, then this is, okay, then we have D0, and then we have D1, and that should be all the parameters, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 parameters. 1, 2, 3, 4, 5. Right, but we're only doing the x parameters. So we're gonna check it twice. So this output value, yeah, this destination output thing. So we're going to check it once by calling it on this axis, and then do the reverse, right? So we're going to do the reverse. Now this returns an object, right? So I don't know if we can chain things together like this. We might be able to. So here's this thing. Here's what we're calling it. So I think we should be able to do something like this. Dot y. Right, so we call it, and then over here is the dot x. Or, sorry, I got that inverted, right? This is the x, and then this is the y, right? Okay, right, so we call it once on the x, and then we do the same thing on the y, and we just want to make sure that, you know, if, error, transcribe, error, DOCHK001. Right, so it's a transcription error, and this is the one we made the mistake with. And then we want to cross-check it against the second one, the second axis, right, to make sure there's no no mistakes with, like, maybe when we copied over the x and y code. When we made the y code from the x code, we may have made a mistake, so we want to make sure we don't do that as well. So now we have this check variable, we have this check variable. And we just want to say, you know, this is int32, right? This is int32. This is int32. And I think we can do this. I don't know if this is going to work with the syntax I did, because we did some kind of weird chaining code, which is more of like an object-oriented JavaScript way to kind of do things like this. I don't know if that's allowed. So check whatever 001 is not declared, because we called it this. So same thing with over here. And what do we got? because I'm assuming we're gonna get these transcribe error because I'm pretty sure we put these, yeah, transcribe error, right? So, 001, right? So, to say, do %d \n, and do is, well, do, and then printf the check value. That's not do, that's d0. Do, and then do check whatever the heck. And let's just take a look at that, right? Let's take a look at how wrong that is. We have some code duplication as well with our tests, so that's kind of annoying, where it's like, yeah, so we're getting a 2. The check value has a 1, right? So in our test case, right? In our test case, right, we're expecting to get a 1. Oh, are we expecting to get a 1? You're expecting a 1. The check is getting the 1. Okay, well, they're not matching. That's for sure. It looks to me like do is the thing that I... God damn it. Two. Well, they don't match. And this is expecting a 1. It's expecting a 1. Did I get this inverted? Because how the hell is this? We know the code doesn't match, right? But this test case passes, right? This test case passes with what's going on here? This test case, if we don't do this check here, all my test cases pass, right? Oh, we better look at the test index, right? Maybe the so right, this is failing here. Okay, so yeah, we should look at the test index, right? Maybe I think I might be looking at the wrong test index. So printf ti %d \n and the test index. So I think I'm looking at the wrong test index. I think that, you know, I added this in, so I thought I was looking at this test case. I think that there's other code that doesn't match my expectations here. So yeah, the test index is 0. And the code that's inlined here is actually working correctly, but the code from this function is not. Okay. So now the question is, well, why is it? What's different about this code? Because I thought that we kind of had done everything the same, right? Well, obviously we haven't. I don't know where the mistake is. Oh, wait. Is the upscaling formula? Nope, we changed the upscaling. So I think this function is probably the perpetrator. Just my guess. I don't know if that's true. If upscaling, we're gonna so maybe seal F32 or float 32 are wrong, right? So seal native, floor F32 calls floor native. It's called seal native. Okay. And that calls the polyOGL seal function. So now the polyOGL functions, are those wrappers wrong? Let's go look at that. So floor native, we're calling this floor function. That looks correct. And the seal round is calling, round. Okay, are we calling different seal functions here? Seal F and floor F, right? And over here it's seal F and floor F, right? So yeah, I don't know. I don't know why these functions are different, but they're not the same. They're not the same function. And we can confirm that from our testing. Let's change this to make it more similar to the other code. So define native seal. Right? And define native floor. And let's just make sure that if we pop these in for the other one, that we still get the error, right? Native seal, native floor. Um... Oh. Fluorinative and Gaia. Got that inverted. So this is seal native and floor native. Okay. So seal native. God fucking damn it. I gotta go get my mask so I can smell smoke. Fuck. So seal native and floor native. Okay, so we're expecting that this little refactor, we're still gonna get that failure with this like little local test that we're running. And if we're not, that means that those functions, right, transcribe error. So we still got a transcribe error, so that's good. And it does mean that we can take so let's go look at this. Let's look at this in a lot of detail here. So we got this. That looks all the same. Plus flooring this. Actually, this isn't flooring. This is casting to float, which is a truncation. So let's do SX1 and S1 are the same thing. S0 and SX0 are the same thing. DX1 and D1 are the same thing. DX0 and D0 are the same thing, right? Well, what about where we're placing this offset here? Perhaps if we... Let's try to get the logic kind of... Let's try to get this logic kind of... Let's reformat this formula so that it starts to look more like what's over here, right? So we have... Well, first of all, I don't know why this says make U32. I don't think that should change the logic, but it shouldn't be a make U32. It should be a, fuck, goddammit. I'll be back. Okay, so this should be int32. I don't think it'll make a difference, but we can, let's throw that in there, right? Because it's actually supposed to be int32. So let's just define, make int32. I don't think that's going to change things, but we need to just make sure the formulas are as similar as possible to each other to see if as we do that, if we still get the crash where they don't match, and figure out why they aren't matching, right? And we know that the formula on my right monitor is the correct formula, as far as I'm concerned. Um, so we know the formula is correct over here, but something about over here is wrong. So let's just try to rewrite the formulas so that it kind of lines up with over here, right? So sure looks to me that the fender is this upscaling thing. So you know what? Maybe I don't understand what upscaling, I'm gonna say that 0, maybe with the upscaling, I don't understand how the logic is supposed to work here. Yeah, so my guess here is that if we change this to upscaling greater than or equal to 1, right, that's one of the differences we had. I'm gonna guess that that's gonna make things fail, but it's gonna make them match. I'm gonna guess that I just don't understand how C code is supposed to return a boolean. That's my guess. Nope. Transcribe error. So let's move this over. Let's say, for whatever reason, it seems to me that passing this directly in may be some type of failure state. I have no clue why. But let's just assume that, you know what? I think that could be it. So let's say, put these two together. And we're just going to say upscaling X and upscaling Y. And the upscaling on the Y formula is over here. So let's take that. Upscaling X, upscaling Y. I have no clue why that would... I don't think that's what's going on. But right now I am at a loss here, so let's try that out, and yep, still no deal. What if maybe this value just... What if this is just not returning a value? Do we forget to... Maybe this function just doesn't return a value? No, we have it here. So this int32... oh, because we got this inverted. Right? The first value is if it's upscaling or not. Okay, so we're just being completely stupid. So yeah, if we look at this, we just have the parameters inverted, right? So the first parameter was if we're upscaling or not, and the second parameter was the value, right? So, so we have this kind of wrapper function inverted. Okay. So now that we figured that out, I mean, we may have that mistake also over in, I think we made this version of the code over here as well, maybe, in the polyfills. Maybe not. Oh no, we have it over here. And we have the same deal. We have the same deal with this, right? So the first parameter needs to be if we're upscaling or not. And the second parameter is the value we're working with. Okay, cool. So now that we have that change there, let's give that a run, right? Let's give that a run now that we've refactored that. And we're going to expect them to match this time. We're expecting not to have any transcribe errors. And we're also expecting that, we're hoping all of our tests are going to pass, or at least the current test we're failing on is going to... Transcribe error, huh? It says transcribe error, but then they look like they match. Well, actually, D0 is a different thing. Right? D0, we want to check against DO, not D0. We want to check against the output. Yeah, wow. Okay, I need to never call 0 when I actually mean 0, because that's actually leading to bugs in my code just from the vernacular of the terminology I'm using, you know? So test index 22. Let's go look at that. And test index 22, and MG is 1. So if we look at MG1, rec source mapped to dest, god damn it. So we got this like 8 and 7, 8, 9, right? And then 11 to 23. So let's go map that out really quick, right? So we got 7, we got 8, we got 9. Then we're trying to map that to 11, 12, 13, 14, 15, god damn, this is going to be more, 16, 17, 18, 19, 20, 21, 22, 23, right? So, actually, yeah, 11 to 23 inclusive. 7 to 9 to start with. 1, 2, 3, 4. Okay, so now that we have that, does that all evenly partition, right? Looks like it might be chunks of 4. Not chunks of 4. 1, 2, 3, 4. There's an extra here. So if we're expecting... We're getting 17 when we're expecting 16, no? Or we're expecting 17, but we're getting... So I see the idea here that, you know, that this, right, that's the dead center, right? The idea is it's the dead center, and therefore H should map to 17, not 16, because it's the dead center, right? That's the idea. But it's not. Because when we upscale, we're flooring, right? Is that what's going on? No, when we upscale, we seal. When we upscale, we seal the result, so we are expecting to get that 8 to map to the 17. Okay, so I guess we're just going to add this case into all the little cases that we've been writing. Alright, so the idea here is, right, that if we have this, that the 8 is in the center, right? That I'm running out of room, so I'm just kind of drawing it out the best I can. Well, you can see kind of what's going on here. Right, this is why we're expecting... This is why we're expecting it to go map to 17 rather than the 16. But that's not what we're getting. So now we gotta go in here, and we gotta be like, okay, well, we have this value 8 that's on a range. The range starts 7 to 9 inclusive, and then it maps to a bigger range. It maps to 11 to 23, and we're expecting 16, right? So that's the case. So case 1123 center, and we need to add 6 more here, right? So we got 6 more entries. And then 1, 2, 3, 4, 5, 6 tests total. So we'll change this number as well. And now we'll give that a run and see if it fails. It fails right here, right? This inline formula kind of just fails us. And then try to figure out why it fails us, right? See if we can derive some of the calculations and just see what happens. So for whatever reason, rec source for this test case seems to pass. Right, so test number 22. Let's make sure we got that correct. 8 on a 7 to 9 range, 11 to 23, and we are expecting, we're expecting, sorry, we're not expecting 16, we're expecting 17. My bad. Alright, so let's look at that diagram. We're expecting 17. So this needs to be a 17. Okay. And so we're getting a 15.43333, which even if we upscale, it's not going to get to where we think. And we give it an 8, right? So 7, 8, 9, right? So 8 is directly in the middle, and yet here we are, just not making it here, huh? Because even if we upscale that, we're in trouble, aren't we? So we originally designed this for zooming in, so maybe we just want to rename some things. If it's in the complete center, then what, we're expecting like a 16 point something something something. Okay, so we're just gonna have to be like, you know what, we're just gonna have to... If, my bitrate sucks right now. God damn it. Why am I dropping frames all of a sudden? Okay, so... Okay, so this entire situation... Okay, so if abs... So... So, if the delta is less than or equal to 1, we don't care. We're just gonna skip it. Otherwise, if the delta is significantly different, then we're gonna skip it, right? Just because I'm getting sick of this. So, unless the delta is off by more than 1, we're gonna say, you know what? It's good enough. It's good enough. And then, unit test helper. Okay. So I made like a little absolute value helper function here. And yeah, we're just gonna skip this. If it passes for this, we're just gonna skip it. And then we will also, you know, if some of our functions are off by 1, we're just gonna say screw it, I think. And the function works for what we need it to work for. So, too few arguments. Oh, hold on. Oh, else, if, okay. Yeah, I think that we just need to lay this to rest. Nested functions. Okay, so we got our bracket balancing really screwed up somewhere. So if this else if this, and so it's either here that we're screwing up our, oh, hold on. I see. So it's not equal to is no longer the case, right? Okay, I'll be right back. I gotta take a break. Let's do that. take me like 20 minutes. I don't know. Okay. So, I think what we're gonna do is if this delta, not less than or equal to 1, if the delta is equal to 1, right? So, if this delta is exactly equal to 1, we're going to skip it. If it's greater than or equal to 2, then we have a problem. And if there's no delta difference, then we're going to be like, hey, you've got some good math, right? And we're just going to, we're going to have to clean up the functions we wrote. And, I think the best possible scenario for what we're doing right now is just getting all the tests to pass, and then, so right here we got, you know, the expected and actuals are off by 1. Let's just, for this function here, right, so, let's go find this. So in here, we're just gonna say, you know what, if, if, so if dst dot x minus dx, right, and the absolute value of that, right, so AAC 2020 fragcom abs, less than or equal to 1, and AAC 2020 fragcom abs dst.y minus dy less than or equal to 1, right? So if both the absolute values, the deltas, if it's only off by 1, we're going to say screw it. Plug. We'll decide, we'll actually make a list of very specific cases that we'll allow. So this case here, we're just going to say, you know what, if the test index, right, if 22 equals the test index, hold on. So, if this and this, right, and 0, or, and then the different test cases that we're going to allow, right? So, or 22 equals the test index, right? Or, you know, 22 equals the test index, right? So this is going to be kind of hackish. But the idea is that these are the cases, the off by ones allowed off. So we're just gonna make some allowed off by 1 cases, and we're just gonna get this working. So we're gonna say, screw this. We've been messing around too much with this, trying to fiddle with this. And the thing is that we just really want to right now use this for zooming in and out. of something where pixel perfectness isn't exactly important. It's just important that it looks good, that it looks proper. And we're getting something that looks proper. And it's working mostly for all the situations we need. So we're going to say, you know, log skip off by 1. And then a void pointer to 0. Okay. So let's, so this is number 22, right? So we're going to just go through different test cases. And any test case where we look at it, and we're like, you know what, this is just off by 1. We're just going to accept it, right? So 23. So 23, though, this is worse. This is, we're seeing... Well, first of all, MG is 1. And we might find that that function is just not doing it for us, right? So, if we go look at the MG thing, MG being 1. Oh, man. Oh, boy. Almost needs its like own range mapping section. It's so much code. So let's just draw this out and figure out why we're getting 23 when we want 20, right? Because that's a big difference, right? So we have like 7 and we got 8 and we got 9. And then we're going 11, 12, 13, 14, oh god, 15, 16, 17, 18, 19, 20, 21, 22, 23. So we got this big range here. And this is on a 7 to 9 range, right? So we're expecting that because we're on this 7 to 9 range, right? But if this is the maximum value, right? That this should also be the maximum value, right? That makes absolutely perfect sense. And that's not where we're getting, right? So here's what we're gonna do. We're gonna figure out if it's a seal or a floor that gives us the correct answer here. And whatever thing gives us the correct answer, we're just gonna go with that, right? So, and then what we're gonna do is, rather than making exceptions to this code, we're gonna consolidate down to one single function. Make sure the function gives us something that's a sane value, not like this. But yeah, this should be all the way over here, right? This should not be... That's ridiculous. This sucks, and I hate it. So the test case here seems to be, you know... we got 9. We got 7 and 9, right? So 7 and 9. It's the same case as this, right? And then we got 11 and 23. And then instead of doing, right, we did 8 on the range. Sorry, it's not a... This is a 9, right? Yeah. It's a 9, and it's on a 7 to 9 range. So if we're going 11 to 23, it should hit the 23, right? Instead of the middle, right? So 23. Okay, so let's label this test case, right? And basically what's happening here is we don't have this. We have... Right, we have this. Right, the 9's supposed to map to 23. And that's not what we're getting, right? So we've added 6 more elements here. So this will be 42 now. And then down here, right, instead of 1, 2, 3, 4, 5, 6, 7, we got 7 tests. So right here, we'll just put a 7 in here. Let's give that a run, because we're assuming that it's going to fail. It's going to fail us in our little proof of concept area, rather than in the main test code. And yeah, so it fails pretty bad. Yeah, so this fails pretty bad. We're upscaling. We're upscaling? Yeah, we're upscaling, aren't we? And we really should be downscaling. Yeah, because this we got, expected 23, we got 20, and if we look at this math here, before we made it into integer, we got like 19 point whatever. So that's just off. Yeah, that just seems off. So I lost my patience for this. I think that what we really want to do is the test is really only for downscaling. So let's... So over here, you know, if 7 equals only do so We're just gonna get this working. We're gonna get this working. We're gonna just skip over tests that are if the range is, if we're going from a smaller range to a larger range, we're just not going to allow that. Because I don't know what I'm doing anymore. We just want to get this mapping function working. We already got it working to where it was like looking good. A few days ago, we got it to where it looked good. And then we wrote out this code to test it. And yeah, upscaling and mapping upwards and mapping downwards are two different things, I think. And we gotta, unfortunately, I think we want to make, right now, we just want to make one function that's specifically for mapping in a downwards direction. Because, yeah. So, we're just gonna patch this up, right? We're gonna just patch it up, and yeah, we're just gonna patch this up and say, you know what? Test index 23. Skip upscaling. Only do downsampling, right? We're going from a larger to a smaller is what we want. So we're just gonna comment out the if this case fails because it's going from a skip, because it's going from big to so it's going from small to larger, right? So we're gonna skip it because it's going from small to larger. Our case, the case that we're doing, is going is taking a large range of values on screen and trying to sample a smaller area of a texture, right? So we're gonna skip that case because we're just gonna skip any case where if it fails and it is going from a smaller region to a larger region, we're just gonna skip it, right? We're just gonna say skip, because it's not. So this thing here, so hold on, test index. Thought we just put that in there. Oh, hold on. That actually is going to go up here, right? So, if, and then else, skipping test cases where we are mapping from lower to from less values to more values. Since the use case is using many So let's just make a note here at vid.id and $23 and say 13, make a lucky number. 23, 13. Yeah, so yeah, we're just gonna skip certain test cases if I've flagged them as, you know, I'm looking at it and I'm like, you know what, just screw it right now. We're only gonna say that as far as we're concerned, this code is only supposed to be valid for downsampling. And that's just the way it's gonna be. Okay, so over here, MG is 2. And we're just gonna remove the MG thing where we're like, test this, test that, test that. We're gonna strip that out, I think. We're just gonna keep this function here. But the other functions we were testing, we're not gonna do that anymore. We're just gonna say, you know what? Big mapped to little, I like that. So actually we'll keep that, sure. So what is this? Test index 10. Let's go look where this is called. So the reason this formula is wrong I don't remember why. So it looks like we're re-zeroing that there. I'm gonna guess this function has a problem here in the formula. Yeah, so we're gonna strip out. We're gonna start stripping some things out. And yeah, we need to just strip some things out. We need to just say, you know what? This one axis thing, this thing here, okay, here's what we're gonna do. We're going to because now we're like in more trouble than it's worth right now. This is more trouble than it's worth. This is stupid. This is ridiculous. Right? Sometimes it's nice to write test code, but in this case, I think we are screwing ourselves over, right? Sometimes you write a whole bunch of tests and all these tests, I think, are just serving to screw me over, because all I really need to see is, hey, does it work properly? Does it work the way I expect it to work? And let's just comment out all these tests for a second. And let's just make sure that, you know, we see what we're expecting to see in the output. And then from there, we're going to just, we're going to hone in on the one function that is giving us the results we like for the situation, right? So syntax error, so that's great. So we made a lot of changes to that code, right? So we have a lot of places where we could potentially have busted this up. And now, what function is the GPUView code using? Is it using this or is it using something else? So let's go find that and find out what it's using. Alright, hold on, not this. GPUView fragment shader, right? So what function is this using? Big map little is what it's using, huh? If we go look at big map lit, so it takes this range and it's calling this helper function. Right, get the cluster size, destination pixel. And it's just going to automatically floor, right? The result of that is going to be a floor. So we're going to we're going to just have to take a step back here, I think. It's nice that we wrote, like, all this code, all this test code. But I think this is turning into a rabbit hole. I think that we needed to know what we were doing before we started out this, and we wrote thousands of lines of code. But in the end, I think this belongs in the trash. So we'll create this and say, you just wanted a function that looked correct you wrote some test code and finally got something looking correct, but then your test code checked for up sampling and down sampling and couldn't get the formula straight for both scenarios. So yeah, so we couldn't get it right for both scenarios. We got to think about how we're going to map things, but for now, really, we just wanted something that was going to downsample. So we're just going to put this in a trash and say, you know what, this is let's go into documentation and just say, you know, call it 003 to underscore. And we'll just say, removed, unit tests for so yeah, let's, I know that eventually we need, like, rendering logic that's going to be more pixel perfect for some things, but for right now, this is just too much. We need to, it kind of sucks because we got this kind of sunk cost fallacy, but the thing is we've already spent, like, almost a week on just this one formula. And I would say that is horrible. It's horrible to spend a whole week on this very simple formula. I think one of the dangers is we treated the formula as something trivial. We're like, oh, we just can whip this up really quick. Oh, well, we don't quite understand it. Let's just write some tests. And we didn't quite understand the complexities of what we were working with because we thought it was a very simple problem. But it turns out that range mapping is not as simple of a problem as we thought. So, so the video ID is 145, and the time is, you know, 2 hours, 36 minutes, and 13 seconds. All right, so range mapping discrete units is not a simple problem. So I wonder if we can go on Facebook and see. Let's go make a note of that on Facebook over here. And then yeah, I think we gotta cut our losses and just it's nice to have tests for everything, but this is just bad. We can write tests for things later, but we know that we want our map from a big to a little range, and that was what we were doing specifically. So we just need to be very careful with the type of mapping functions we're using, right? So, Alright, yeah, so I just can't get this to work, so we're just gonna post this. Just, um, yeah. Like, I don't get what's going on there. Yeah, we need to cut, I just need to cut my losses, and, um, um, yeah, so let's just keep on gutting things, right? This is quite shameful that we had a whole bunch of, we got the correct results, and then we spent a whole bunch of time trying to verify correct results with tests, and we just screwed ourselves over. Um, I'll throw that in the trash as well. So this right here, this stuff. We're gonna go lib. This is the fourth thing we put in the trash. So let's make a note of that. So fourth thing in the trash, and then make a timestamp. 242, and let's do 12. Okay. And we also had, like, syntax errors in our shader, right? So, we know we're calling the big little function, right? So this thing here, we don't know what's going on. It could be something in here, right? There could be a lot of things. But we're just going to remove some things, right? So, we're just going to remove this and say, let's trash this. So we're going to trash this code as well. This formula is, like, kind of nice, where it's like, we're kind of figuring things out. And... but right now, we just want something that we don't want multiple functions that do very similar things kind of rolling around in our code. So, we're just going to steal this. Put it in the trash. And we're just going to keep on gutting stuff. And then after we've gutted stuff, this is the big mapping to little function. So this is actually one of the ones we want. And it calls this from here. It calls this. So we want to keep wherever that's coming from. So this thing here we want to keep. But this stuff, the seal or floor kind of code, there's no seals and floors in here, right? So we want to, well, let's just see if that we can get that to run. And I actually really don't like those seal or floor functions. Okay, so this has the results that we want. Like, this is the correct result. So let's not bang our head over a wall. Say, hey, this is the correct result. We're good there. And if we want a little, well, let's so if we're using this, we're just gonna say, let's see if we can trash this as well. Okay, trash this in the 6th. And trashed. We're gonna trash it, and then we're gonna just say, you know what, if I ever see this used somewhere, then we have a problem. So we're going to say, you know, do not use this in your code. If you're doing something like this, where you have this kind of branching, then you're doing something horribly wrong. And so we're going to define the function name as this, right, to make sure that we cannot call it from anywhere, right? And I don't know if that's going to work like that, but let's give that a shot and see if that compiles correctly, or if that define kind of just throws a monkey wrench in our GLSL compilation, right? Because I don't know. Okay, well that still worked. Okay, fine. So these other flooring functions, floor and round and seal, there's still a place for that kind of a thing where we could see needing that behavior. So I'm not going to completely gut that out of there. Now, this one axis thing, the formula isn't quite correct, is it? Because this range... The value on the range needs to be zeroed out. This code here probably zeroes out the range. Nope, it doesn't. So this works because the origins are at 0, 0, but this formula isn't quite correct. So let's try to consolidate these formulas a bit. This one-axis formula, that's nice and all. But we know it's not completely the proper formula, right? So this needs to be, this input value needs to be zeroed out, right? Because then we're adding this back on, right? But let's steal this formula, right? Let's steal this formula. And here's what I'm thinking. Let's paste this in here. Let's just do some weird stuff here. So this range needs to be zeroed out, right? So minus S0. Okay. So we're just going to fill it out like this, and then we're going to go define so SI is the last thing we need here. And it's the big SX, right? So well, this shouldn't be Y though, this should be X's, right? So 0, 1, and 0, 1. Source, destination, right? Everything's X. And then we'll undef it. And this is ugly, but the idea is that I want to have this formula for reference, because this is a pretty good formula. So let's kind of like, we worked pretty hard to figure out what the exact formula for this was. It's not the best formula, right? It doesn't work in all cases, but it works in a lot of cases for us. So we want to just write it in a way where we can kind of grab that formula and use it later if we want to use it, right? So big SX, extra token. That's because when we undefine things, we actually have to delete this stuff, right? Well, I'd say we screwed up somewhere. Because that's sure not what it looks like. Did we write the formula correctly? Let's go look in the trash for the old formula we wrote, right? So let's go look in lib, doc, and then in the trash. I think it was the third thing we threw out. Nope, not that. The fourth thing, maybe? Maybe the fifth thing. Oh, yeah, we have to convert things to float, right? So this formula works pretty well, but it seemed to work okay in here, this scenario. So let's comment this out. I don't know. We just got a lot of reworking to do here. A lot of... well, what's going on here? We never commented that out? Oh boy. Okay, so let's change everything kind of minutely here. So this formula here... Right. Oh, this doesn't... This account... This is one-dimensional, right? So I'm gonna guess we have an extra offset somewhere after we call this, right? Yeah, we have an extra offset here. So if we wanna use the other formula, we had to comment this out. We gotta put this back in. And then we have to comment this out. I'm gonna get this. Still looking good? Cool. So over here, we're just gonna comment this out as well. And then we're gonna comment this out. And then we're going to just copy-paste and change these macros, right? So, copy-paste. And everything that was x is now y, right? Because we're going to solve for the y. And, yeah, y's. Okay, so we're thinking, yeah, that should work. And then we're just going to gut out some more of these functions, right? So we got a nice formula. We're not converting anything to float, so it only works with upscaling, and it only works with, like, it's the nearest neighbor kind of a formula. But it works for what we need to do. So now that we have that, let's kind of clean this up, right? So, so we can get rid of this commentary here. We can paste this in here. We can just get rid of this. And so we're just taking this as the basic formula we need. Right, let's make a note that, you know, in some cases we'll want a float conversion if we want, like, a decent floating point version of this, even though it's not the best formula. But let's make a note of that. We're going to define NFC as no float conversion so that we can keep this, like, if we wanted to make the floating point version of this function, then here's the parts where we would have to, here's the parts that we would have to turn into floats, right? Here's the parts that we'd have to do that for. Just so that in the future we have that for, you know, I think this could potentially turn into, if we're not careful, that could end up one of our macros. So no convert to float. How about no convert to float? All right, if it doesn't, I just want to make sure it doesn't match my kind of like my usual style of macros is, you know, 3 letters or 7 letters. So we're gonna say not convert to float. So don't convert to float, so this macro is just going to disappear, right? It's just going to disappear, and it's going to be like it wasn't there in the first place. And it's just there so we can reference, so that we can reference it and be like, oh, a float conversion could go here. Sure, why not? And then this kind of stuff here, we're gonna nuke this as well. And then this range mapping here, we're gonna nuke this. We're gonna nuke all this, right? So, time is 0, the day, the vid IID, the time is 3 hours, 7 minutes, 44 seconds. We'll move that up to a different line. Okay, so now that we've kind of done that, let's make sure it still works, and then I would like to take my specific test case scenario. Like, I have one very specific test case. Oh, I forgot to... I have one very specific test case somewhere in that test code that I scrapped that I might want to salvage. Or it's like a very specific test case for the exact scenario that I'm using. And the test case for that exact scenario for what I want to see on screen, I think that we can salvage that. I think that, right, so what I'm seeing on screen with these corners here, and how those pixels are getting sampled, we want some sanity of mind that that is actually working correctly. So let's go look at some of the trashed code, right? Let's go look at the trash code and find the right, we have a specific case. And it looks like this is the specific case, maybe SC3 is the exact specific case, or it could be SC4. Oh, this is our true to render test case, huh? Okay, so this was a distillation of the scenario. And this test case was something that we could... Was something that, So SC5. Let's go SC5. And this test scenario was exactly what we were seeing on screen, right? So if that works, we're kind of satisfied that everything works, right? So, the thing is that we just want the map big to little, right? We don't care about this other thing, right? We gutted stuff, so, MG right here is going to equal 1 to 1. Actually, let's cut this out, right? Let's take this and say, hey, this is the thing we want. This is the thing we like. So let's just steal this, copy it. And let's go back into the fragcom stuff, right? Where we kind of removed a whole bunch of tests in the unit test section. Let's paste this one test that we actually care about. Right? And let's call this extern void, this thing here. So we're just going to try to call this. And for this test index, it's just going to be 1 to 1. And so yeah, we're going to throw this back in, right? Because it tested, you know, the exact scenario. And we just want to confirm, hey, this was working. So we scrapped a whole bunch of stuff, and now we're kind of salvaging. We're scrapping and then salvaging, you know? So it's kind of ugly the way we're doing this, but out of all the tests we wrote, this is the one we really care about, right? This one is the one that confirms that what is on screen, that we're looking for on screen, is actually there. So we'll just keep the, you know, specific case 5 and make sure that that works, right? And if that works, if that test passes, yeah, so that test should pass. It should just run still, right? And yeah, so next time we have to think about how we're going to map pixels, we need to realize that it's not going to be as trivial as we think it's going to be, right? So the next time we think, hey, let's just go map some pixels from one range to another, let's be a little bit more smart about it and say, you know what? This is not a trivial scenario. You might think it's trivial, but it's not, right? So for next time, let's just make sure that if we try this, next time we try this... Oh, I see. Next time we try something like this, let's, you know, remember that it's not a trivial thing. All right, we thought it was a trivial. We thought it was a trivial calculation, and so we're like, we threw way too many tests at it because we thought it could be more flexible than it could be. But it's not a trivial calculation. Right, so this looks about correct. We'll measure it out, make sure it's actually correct at the pixel per pixel level. But yeah, I need to take a break. Two, 4, 8, 16. Let's get 16 minutes. I'll be back. Okay, so if we look at this, this is pixel perfect. So look at this. That's 16 by 16. I'm fairly confident this is going to be, you know, right, also 16 by 16. Right, this is 32 by 32. Right, 32 by 32. And if we take it and try to paste it, right, if we paste it corner to corner meticulously, we can kind of prove to ourselves that everything is lined up in a pixel perfect fashion. I mean, we proved it pragmatically, and also visually it looks correct, but let's just take some time to prove it to ourselves by kind of lining these up tip to tip. I'm actually getting kind of scared here. Looks like the trajectory is slightly off. I'm worried now. But let's just keep on going. Let's keep on... Oh, persevere in there. And then bam! Pixel perfect. Okay. So... 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. So it's pixel perfect. We're good. So another thing is we know it's it should be 512 by 512, this little viewport we're looking at. So we can confirm that as well. So now that we know it's not trivial, let's I'm gonna save that on my Imgur really quick. And then we're gonna need a way to render pixels that are there are some pixels that are gonna show up black that actually have non-zero values in them, because the alpha channel is the first 8 bits is the alpha channel. The first 8 bits is the alpha channel, right? So we're really not going to see any changes in the shader if the alpha channel is the only thing edited in the pixel, right? It's a black pixel and the alpha has been changed. Chances are we're not going to see that. So because of that, we want to... We might want to edit the shader just a little bit to make it more obvious when we're seeing pixels that have been edited, right? Non-zero pixels. Okay. Hold on. So my bitrate sucks again. So... drop frames 30%. Okay. Anyways, we need to make sure that we can see pixels that have actually been changed. So, in the shader code, for the GPU view, this is a texel fetch. And oh no, if UV for text.w if not equal to 0, then we'll do this normally, but if the alpha is not equal to 0, then let's do something else. Let's do 1.0 for the alpha. Let's not worry about the details. What I'm thinking is we take the W times 16 maybe. And then maybe only on maybe only do this in the case where the alpha channel is not 0 and sorry. So I'm thinking X, Y, Z, and W. They equal 0, but the alpha is not equal to 0. So it's something very hard to notice because only the alpha channel is being affected, right? And if that's the case, we just want some way to, okay, I'll take the W channel that's not 0, we'll multiply it and put it in all the channels to get some type of weird color. We can kind of see something, right? So let's do that, right? And now let's go over here and give that a run and see if that shader code works. And then try to observe that by changing the offset index and making sure that we can see that pixel that's going to change, right? So we're just mucking with the colors, so it's not an exact view of the texture anymore, but that's because there's certain things that we just can't detect. So you got a syntax error, implicit cast from int to uint. Oh, so these things here need to be a uint and then also that means that if 1 equals 1, we're gonna have to do something like that if we want this kind of weirdness to work in that formula. Okay, let's give that a shot. And then after this, I don't know, I'm gonna do some exercise, take a break, and be done coding this stuff for today, and work on maybe some patent stuff later, or some crate designs. I gotta figure out a crate design for selling acrylic. Oh. So there's no uint, right? So we gotta actually make this a, you know, U32, right? So remember, this code compiles as both GLSL code and C99 code, so it needs to fit both requirements, right? Oh, right. It's not just U32, it's called make U32, right? Because depending on what we're doing there, we have to wrap our casts into constructor-like functions just so that it works both from the GLSL side and the C99 side. And the C99 side can afford to be less efficient because we're only using the C99 side to make sure that the code works. So implicit cast from int to uint. Oh, because it's this thing again. So this is a UVEC4, so this needs to be... Oh, we could change that, right? We could just say divide by 255, and then we could just multiply it, right? We could just multiply it over here. Make these point zeros. So define M for max, and undef M. And over here, this is going to be times M. Right. Okay, let's give that a shot. Okay. So interesting. There was a lot of stuff that we thought just wasn't set, but now that we're inspecting it like this, it's like, holy crap, there are a lot of things that are actually being set in here. So, I know a lot of it's probably the, a lot of this stuff doesn't matter. And so we need to... As long as we keep all the variables sequential, which we're not, right? Because we have these variables here. We need a way to erase these values so that we can focus on what actually matters. So, holy crap. And then if we go over here and we press U and then we go over here, oh hey, we see little colors here, right? So we see those colored blocks, so that's cool. Yeah, I was not expecting that. That's probably like a whole bunch of like randomness that's left over from some of my test code, putting like just kind of throwing on values. So we want to erase what doesn't matter. Let's go into the PAINT5D system. And this is the debug that we're using. That's putting these things in these corners. Right, it's this corner, that corner, and these specific values. What I would also like to do is do so I'd like to clear unused for specifically PAINT5D. So I want just a little function here, a little utility function that's gonna in Tau Depot. In Tau Depot functions, it's gonna clear the unused variables. So this putter variable, we're gonna use that init. Let's put it above the init. So let's just say clear unused. Right, so clear unused variables, that's the section. Okay. And we're going to go through Tau Depot's memory. If we look at Tau Depot's data, we should be able to see certain places where there's constants. And we know we want to skip over these variables. They're specifically in corners just because we're being weird. So we're going to say this is the max valid variable index for sequential PAINT5D variables, not including the debug variables. Alright, so we're going to keep this here. And then what we're going to do is we're going to say, you know, for int32 dex var equals 0. Dex var is less than or equal to dex max. Call it var max. That's what we called it here. Okay. And so these are fine, but this dex var here is going to be actually called dex var, right? We can keep an example of what that might be, right? And U32 x0. Actually, we don't have to hardcode that at all. We can just say, because we're zeroing everything out. Right, so we just want to zero it all out. We want to zero it all out, and we also want to skip certain things. So, you know, if... Right, we have these certain debug corners. Debug 1, 2, 3, 4, right? If we hit any of these debug corners, or debug cases, then we're gonna skip over. We're gonna skip over them, right? So let's copy this, paste it down here, and undef. D4. Okay. So if D1 equals dexvar, continue. Yeah, we're just gonna skip over these, right? So not. So we're going to skip over these because, well, it's not just that we want to, it's not just that we want to skip over them. also... It's not this... We're skipping over them because we don't want to... we actually still want to see that debug pattern, right? So... 1:45, and the time is 3 hours, 57 minutes, and let's say 58 minutes. Okay. So we're just going through everything and zeroing it out, but only if it's an unused variable, right? So any unused variable gets erased. And so we're going to go through dexvar to var max, but these debug variables might not be, might be weirdly positioned. Oh, hold on. So this is completely, this is wrong. We want to go from, D0 equals var max plus 1, right? Outside. And then D1 equals... it's a 32 by 32 section, right? So we know it's 32 times 32 minus 1, right? This is the maximum possible index we could have. But we know that as far as when we start, we want to skip all of the variables that are in a big strip here, right? So we have 1, 2, 3, right? All 1 to 10 here. All these variables in a big strip. We want to skip over them. So we have a maximum variable, the variable max index here. And we're going to we don't want to erase any of those variables. So we're going to start iterating past that, right? So we're going to start iterating at D0. And instead of var max, less than or equal to D1, right? So D0 to D1. My bad. And at some point, we might encounter one of these variables. We want to skip over them. We don't want to erase the debug variables. But otherwise, we're good. Okay, so let's give that a shot. So the idea is that when we press that U key, it's going to set the debug variables, but then it's also going to erase some memory. So 32 times 32 minus 1. I don't know what's wrong there. Expecting a comma. I'm sick of this. Oh, there's an extra comma. I see. One, two, three, four. Let's get some space. 1, 2, 3, 4. And, let's kind of space things out so that they are kind of symmetrical, right? So we got a +1 and we have a -1. Does that make sense? 32 times 32 minus 1 because we don't want to be out of range. +1 because we don't want to cover the maximum index for the valid variables. We want to skip over and only look at invalid variable places. Okay, cool, that makes sense. So let's give that a shot, see what that looks like. And we forgot to clean this mess up, so let's do that now. Okay. Okay, so now what we're going to do here is we're going to hope, it looks like, you know, we're compiling, so that's good. And we got this kind of craziness, right? But if we go over here and press the U key, and then we go back, we got more erased than what we wanted. Okay, so that's erasing more than we're expecting, right? We're expecting these ones not to be erased, and they are getting erased. So what's up with that? Because we said, hey, it's equal. If the index is equal to these, let's not erase anything, right? And things are getting erased. So WTF? Perhaps we got this wrong. No, that looks correct, right? So the index of these different variables. And the variable index is the last thing right here. It's the PAINT5D system. That looks correct to me. Perhaps the indexing is wrong. Well, it's the PAINT5D system, right? This is relative to 32 by 32 block. Right, so 32 by 32 is like 255, right? 32 times 32, well, is 256, right? 1024. It's 1024. Is that correct? Oh, hold on. So we're just going out of bounds. We're going way out of bounds. Because each one of those variables is a 4x4 cluster. And so we should only have 16 by 16. 16 by 16. Yeah, 256. So it's 16 by 16. 16 by 16, not 32 by 32. Because each variable takes up 2 by 2 pixels. I don't know if that's going to fix the problem, but it's definitely going to... That was definitely erroneous code. I don't know what I expect to see with that kind of wrong code, but it's definitely something that's wrong enough to where it could be making... It could definitely result in something like that, where it just looks wrong like that. So, fix that. And, right, 16 to 16, so we're iterating over too many points. And if we're outside of the bounds, that's kind of undefined behavior, right? But that also gives me a question of, okay, yeah, you had that undefined behavior, but why didn't the function catch it, right? That's something where you would think we would have some type of... So look at tau depot put for a second. So this value right here... Oh, this variable needs to be... Yeah, this variable needs to be in this range, right? Yet, this bug never got caught because... Oh, we never got caught because there's no way you can ever use an invalid value, right? Because it's only using 8 bits here. So... Starting to regret using very specific bit widths for everything because I'm getting burned quite a lot from that. So it can never go out of range, right? So basically the range check in our loop was, you know, using the 32-bit, And then when I used the put, though, it got implicitly downcasted, right? That's what happened. So the best we can do is just say, you know, let's just make a little error message, and I'm gonna guess we're gonna need an error macro for that, but let's just try to run that first. But yeah, so I see how that happened, and I see it makes sense. It makes sense. What happened? Yeah, so no error macro, so we have to define define ERR AAC 2020 tau depot halt. And then down here, we'll undef that. Okay. Okay, so now if we press the U key and then go over here, excellent. So we've erased only the variables that we don't care about, so that we can just have a clearer picture of kind of what's going on here, right? And then do a P for pattern to load in a pattern here, and then do Y to go through these patterns, right? And if we hit this, right, and we go back over here, I don't actually remember what number variable it is for the variable we want to look at here. So let's just say that, so we got this kind of like bluish color for everything. Let's say if something's exactly 15, then we're gonna pick a very choice color just to help us debug here. So I'm fairly certain that this is correct. So we'll close this. And yeah, so here we're just gonna say, you know what, if just copy this, right? Let's copy this and paste it, and then modify this else, right? And turn it into else if. And we're gonna say exactly equal to, right? So if it's exactly equal to that, it's the max value, it's that 15. Then we're gonna say we're just going to say, I don't know, let's multiply it by 16, and then the other things will just be 0. This is kind of lazy way to do it, but so I just want to detect things that are exactly 15 in a really easy way. So we're just hacking something. We're just hacking this together, right? We're kind of just right, because it's just a shader for diagnostics. There's no performance that we need out of this. So we just need it to work. So now these green pixels, we can see these are things that for whatever reason are exactly 15 on the alpha, and then on the other channels are 0, right? So now we can go over to here, we can press U and then go over here and say, oh, we got nothing that's green except for this, but that's like the debug section. And then if we press P for pattern, and then go through here, right, so that we can kind of see what we're looking at, and we max this out, and then we go back over here, we can see, hey, that pixel is green right there, right? So right here, I guess for whatever reason that value doesn't persist. I guess that has something to do with like the initialization. Interesting, the value doesn't persist. What implications does that have for... Okay, well, we know the value doesn't persist, that's fine. So if we press U and go over here. Oh, we go over here, we press U to debug, and then we go over here. And now you gotta press U to debug. Actually, you don't even have to press U to debug, we already got the debug pattern. What we really care about is just going up one already to, like, all the way up to the top, and if we go all the way up to the top, we can see that kind of pixel right there where my mouse is. Right, so here, it's getting erased, and then once we go up to the top, we can see it. You know, why is it... So the next part is, we want to figure out our subtexture pushes, right? Like, why doesn't the subtexture push work? And this is part of getting that to work, right? Where if we have this here, we can, you know, cross-check it. Okay, okay, I'm kind of tired right now. Well, yeah, so we have... But yeah, now we have this little debug thingy. And it's going to tell us when we're trying to look at those pixels and try to figure out what we're doing wrong. We can definitely kind of detect, okay, well, this is this right here, this cluster of pixels right here is stored on our offset index, right? So figure out like why a partial texture push is not working, right? So let's go look at the agenda before I stop coding for the moment, before I go off and do something else. Let's go look at our agenda and see.